the bottom of the bonding pairs and the lone pairs, I draw it as an L shape. So a linear molecule, followed by the trigonal planar, followed by the tetrahedral. And the difference between these is the fact that up here it is 2 bond pairs, 3 bond pairs, and 4 bond pairs. And this is this part of an L, coming down, a capital L. And as you increase your bond pairs, you're seeing that your bond angle is getting smaller. Okay? And I put these in because the SEC will ask you questions. Name 2 shapes of things that are AB3, so, or QX4, or they use words and letters. And then the bottom of my L goes along here like this. So this is the bottom of the L. So this is my L shape. So when I'm coming down my L, I'm just dealing in bond pairs, essentially, coming down here. But when I go across the bottom, the total is 4. So 4 bond pairs would be a tetrahedral shape. The trigonal planar, this is how we would just draw it. If this was A, we'd just go like this, B, B, and B. And then for bent, and I give 2 names for something that has 2 bond pairs and 2 lone pairs, I say bent and V-shaped because the SEC can't make up their mind. So you just give them both and then happiness is. But if we are doing something that has 2 lone pairs, this is how we would represent it. So you just have to get in your head, how many lone pairs do I have? How many bond pairs do I have? And then work it out from that. So that is the kind of the relatively easy part of it. But you can see here there are 2 different shapes for AB3. So AB3 can be trigonal planar, but AB3 can also be trigonal pyramidal, or just pyramidal by itself. They'll accept that as a name. And the reason it's pyramidal is because this is slightly like triangularly in shape. And this is bent or V-shaped because it is bent or V-shaped. Do you have any questions on that? Because there has to be something. Like, you are good, believe me, in terms of the quality of the work that you send me, but there has to be questions. So is there anyone brave enough? What's the worst that can happen? You figure something out and you help someone else. Yes, no? Okay, well, if you're happy, I'm going to flip forward. Is that okay? Lads, you don't even give me nods of heads. I can see all your lovely faces. Thank you, Jane. I just need something. Okay, so on the next page, you should have filled in the table. So it's the idea of 2 bond pairs, you're a linear molecule, you're 180 degrees. 3 bond pairs, you're trigonal planar, you're 120 degrees, and BF3 is an example. And for the 4 bond pairs, you're this thing called tetrahedral, and it's 109.5, and you are methane is an example. Okay, so that should be filled in. Similarly, for the going across, I'm going to come back to this in a second. I'm going to go back to this. So similarly, when we do 3 bond pairs and 1 lone pair, it's pyramidal, and we've 2 bond pairs and 2 lone pairs, it is V-shaped or bent. And once you start adding in these lone pairs, you reduce your bond angle by 2.5 degrees. Okay. And we have this, it's this rule. So the thing is the valence shell electron pair repulsion theory, VESPR for short, and this is a rule. And sometimes they'll ask you why is something pyramidal? And it's this rule helps you figure it out. Okay. So I'm going to change my screen if that's all right. So you tell me when you are happy and ready. So can I ask, so somebody's actually going to have to answer me here in the next page where it starts with once lone pairs are present in a molecule, the following rule comes into play. How much space do you have on that page? A lot or a little?
1 line.
1 line, but is it full of stuff underneath it? As in, is there a gap underneath it, or it's blank? It's blank. Yeah, so there'll be like a couple of gaps to write some stuff, but then there's some space to write extra. So is it okay for me to change this to a different page? I'm taking it as a yes. Okay, need to find, go to this whiteboard. So obviously for the rule, I am not writing in lone pair, bond pair, or so the rule is LP is greater than LP, BP is greater than BP, BP. I don't know why you were not playing ball this morning. Okay, so what does it mean? So it means that if you have just bond pairs, they will repel as far as they can. Okay, so if you've just bond pairs, so something like BF3, they will get as far away from each other as they can, and that's why they have the 120 degree bond angle. That's as far as they can get away. Once you put one lone pair in, so one lone pair present, so that, think of lone pairs like bullies. They really don't like anyone near them, and they will push people away. So they're really mean. So the bond pairs just want to get kind of close to them, and they say no. So if one lone pair is present, it will actually push the bond pairs closer to each other. It repels them. So then we have the example of if we compare BF3 versus NH3. So NH3 is the thing with the lone pair. This is a 120 degree angle versus the 107 degrees. So that lone pair now has bullied the bond pairs and really squashed them down. And then the last part, the LP, is if you have two lone pairs, well, they actually repel your bond pairs even more. Even more close, even more, no, I don't want to write that way. So the fact that you will have one bond pair or one lone pair there, it's going to push all of the bond pairs away from it. Your bond angle gets smaller, and they repel bond pairs even more, so bond angle is even smaller. So if you were to compare something like BeCl2 versus H2O, so they both have two bond pairs, this guy is 180 degrees, whereas this guy is 104.5. So lone pairs really push each other down. So in terms of the result for this particular rule, the result is the bond angle is going to be different than expected. When these lone pairs are present. No. Yeah, so reducing your bond angle and changing your shape. So does that make sense? So when you draw your molecules, you have to work out, are there lone pairs present? And really the rule would be this. Let me change my color. We will change it to a blue. So the rule would be in reality that anything that lives, oxygen and nitrogen will be the most common ones with lone pairs. But it will also be anything that is in group 6 and in group 5. So in the homework questions, they asked, was one for the one that you've just done was for bonding between hydrogen and sulfur. And if you look at what the group sulfur is in, it is OS. So you know that hydrogen is H2O, so you could figure out then that sulfur is H2S. And then sulfur, it'll have 2 lone pairs, and it will be V-shaped and bent, and it'll have that 104.5 bond angle. So you need to be able to infer from a different element in the same group how that might behave. So this is V-shaped or bent because it has 2 bond pairs and 2 lone pairs. So I'm going to write the shorthand, you have to write it out. 2LP, 2BP and 2LP. And those lone pairs push the bond pairs closer together, reduces the bond angle. Okay, so the lone pairs will really only be groups 6 and 5. So how many people did we get in total? I can't see my share. Here it is. So on Thursday, I'm debate. Yeah, we'll probably do it live. But if you can get your hands on 2 sizes of marshmallows and some toothpicks, or some 2 different sizes of jellies, so like a big jelly for your central atom and some small ones for the side, and if you can get super small ones, you can make lone pairs. But if we were to do this in lesson, we would be making them and eating them, because that's always fun. You only eat them if they're correct though. So if you could get those for Thursday, that would be brilliant. Lads, please ask a question. Please. Oh, I have a question. Are the shapes in the book? The shapes will be in the textbook. Definitely they're there, and I gave the page numbers, I think, in the blurb. Does that answer your question, Ben? Yes, no? Okay, is there anything else? Or are you just all going to suffer alone, or you're super happy? Okay, we will take it that you are super happy. So I will let you know about Thursday, but my gut says we'll do it together, and we'll do some eating and might have a giggle. Okay? So if you have no questions, you are free.